All right, we're talking about Phoenix, obviously, and I'm going to talk about gauging progress, where the framework started and where it's headed. And before I get in too deep into where it's headed, I want to talk about Phoenix 1.3 just a little bit. I know if you've watched my last couple talks that you're probably tired of hearing about the web directory moving 2 levels in on your editor hierarchy. So I'm just going to touch on some of the confusion a little bit around some of the new ideas and what we can learn from that. But before I get started, I got to plug Dockyard. Dockyard pays me to spend 75% of my time on open source development. Okay, so this mic needs to be closer. I'll just look straight down the whole time. All right, is that any better? All right. So I have a problem of like looking down during my talks, and like I try to like focus rehearsing like looking at the crowd. So now you're training me to abandon those efforts. But okay, someone holler out if it's hard to hear. But Dockyard pays me to spend the majority of my time on open source development. But we are available for contracting. We do Elixir development. We have a team of Elixir developers. So if you're interested in our help, please get in contact. But let's talk a little bit about Phoenix 1.3, and I promise it won't be a review of my previous talks. If you haven't seen the previous talks, we moved the web directory, and we have new generators. Actually, it was a bit of work to get this in place, but we don't have any big new features with 1.3. It was really about a new directory structure and new code generators for people getting into the framework and starting to build real applications. But we found out a few things, not us personally, but I think the community at large. We've learned that programming is kind of hard, actually. And thinking about programming and thinking is actually harder than not thinking. So I think that we've put a little bit of pressure back on newcomers and developers in general to actually think a little bit about the design of their application. And this has caused some people to like physical pain, I think, about like they kind of get stalled and like, oh my gosh, this is so hard. But it turns out it's not so hard. It's just you have to design with intent. And we've seen mostly good reaction. So I think I've been really encouraged by the discussion and the positive reaction to our 1.3 changes. By and large, it's been great from both experts in the community who have complained about us not pushing newcomers in a better direction for maintainable applications, but both from newcomers as well. Because this is a big balance to strike where we want to have a great out-of-the-box experience for people that have been in the community since its inception, as well as people that maybe it's the first week trying Elixir out, and they're going to try to spin up a Phoenix app to build something real. So we've had some good feedback. Like this user said that as a junior developer, they're really thankful for the new changes, that we're consciously like pushing them towards better design and kind of helping gently guide them in the way that we think is going to lead to a better solution. But it hasn't been all positive. Oh, this is another person that said that they've had the best time rewriting in Phoenix 1.3. So it's like always like roller coaster. Like you read through like you announce a release candidate and everyone's like, yes, this is the best. But then you hop on YouTube comments and you're like, oh. So if you go to YouTube, just go for the comments. That's why I go. Just like Hacker News, I visit just for the comments. So this is like my Lone Star keynote came out about Phoenix 1.3, and this was like the first comment on the video. And I normally don't engage like really negative YouTubers because that's not really a positive improvement to my life. But this was like the only comment on the video, and it had like a couple thousand, like it was getting thousands of views. So I was like, I didn't want this to like devolve into people thinking this person was right. So I decided to engage with them. They may be here. I don't know. If they are here, let me know. But so yeah, this person, it's just, the ideas totally went over their head, and they said that this is like we removed the only magic thing, which is a root level web directory, and they said, oh, this is just another case of magic folders, forcing you into a specific directory structure. So tragic, Rails never dies. And like I don't know, this comment doesn't make any sense. So anyway, I was like, I've got to respond to this. And I think I was talking with Jose, and I was like, I'm I responded to this guy on the internet. But look at the bottom. Like, I actually won an argument on a YouTube comment on the internet. He apologized and said I was right. Yes. So, the key thing is, like, it's good to take negative feedback. Not all people are worth engaging with, but I do think discussions around programming, everyone has their different tribe, can get intense, but it's better to, like, be respectful and, like, try to educate people, which is what I did here, and this guy actually appears to have changed his mind, which is great. But for the most part, the negative feedback hasn't been like this toxic, ignorant comments. It's been more like, I feel it's more difficult to work with Phoenix 1.3 compared to 1.2. In fact, some person said they were no longer going to be able to develop or use Phoenix because of the 1.3 changes, that they were going to use, I think, PHP or Java instead. Which is funny because, like, literally it's just the generators, it's a suggestion of, like, a directory structure change. Like, there's no APIs change or anything, so, like, you can do whatever you want. But for the most part, the people that actually want to provide a positive feedback say that it just feels more difficult. And furthermore, someone said that it's just context. This new idea is just a plain bad idea. And it's interesting because there's two sides where people are like, yes, this makes total sense. And then people hear about this, and, like, this individual thought that, Phoenix is just a web layer. Why is it trying to have influence what my application looks like? But it's funny because, like, Phoenix 1.3 was made exactly to accomplish that goal to enforce that Phoenix is just the web layer. So I think that there's just some confusion around these changes, and I don't know that it was avoidable necessarily. I think by and large, it's been positive and resonated with people. But I think there are some misconceptions that we can fix. One is just to reiterate, we've said this from the beginning, but our generators in Phoenix are just learning tools. Like, this isn't like us prescribing of, like, this is the way that you have to write your code. This is us saying someone new coming into the framework, this is a way to gently guide them into what we think is going to lead to a more maintainable application. So for people that come in and they see us generating a module with certain functions, they think that this is, like, the only way they can write their Elixir code within a Phoenix project. And it's just not true. These are the starting point of your application, not the end of your design. So I think that's another problem where people see this module that was generated and they suddenly think they can no longer create a new module. So a common theme is some people are concerned with this context idea that it's just a dumping ground for functions, that they're going to have thousands of lines of code in a module. But we'll walk through, I guess, where we can guide people to away from that fear. Because really, this idea of context, some people have asked, like, why did you name this a thing? Like, why not just say, hey, it's a module and you write functions? Because that's the way we describe it. Like, anytime someone says you're introducing this new idea and pushing it on the community, I always fire back with, like, literally we're asking people to write modules and make them well-named and put well-named functions inside them. And then maybe think a little bit about the relationships between these modules. But the reason we decided to call them, or give this thing a name, is because if we just told people, hey, the best way to write an application is to write modules and functions, while that's true, we wouldn't have improved anywhere from what we had with web models, right? We would have ended up with people just writing a module, putting some functions in it, and then anytime they had a new feature, they'll just create a new module, write some more functions. That's not bad, but now they have implicit relationships across their application. They're not thinking about the boundaries in their system necessarily. So I think there is an idea here, whether we want to name it or not, it's about thinking about the boundaries of your system, whether that's across your across separate applications or within your application. The more we can think about boundaries, the more maintainable code we're going to have in the long term. So it's not just a matter of def module, write some functions. It's a matter of actually thinking about the boundaries of your domain. And this is kind of a hard thing to do. And what's even harder is some people hear us say, write modules and functions, think about boundaries. And one thing we emphasize is that if you have this boundary in your system, that the boundaries talk to each other through a common public API, and that they shouldn't reach into some nested module within this context. So people hear that, and that's when they think, okay, I'm going to have a 1,000-line module. But I think, again, this is like, just like if you're coming from an OO land, like when you read like a suggestion, like don't write 100 line, don't have a class over 100 line, and then people like take that to extreme, right? Where they just like, they hear a suggestion and now there's just like this golden rule that you follow. That's not what we're pushing. It's just we're giving you a starting point and suggestions to think about designing maintainable applications, and that's it. So it doesn't mean you're never going to call into a module 2 levels deep and call a function as a public interface. It just means think about reaching in across a boundary, and maybe if you were able to encapsulate that, instead of having callers reach in, maybe it'll lead to a better design. So here's just a basic example of that. So this is just lifted out of a project I was working on. There's a notification system that is going to subscribe to platform events across this entire product, whether that's Elixir application, Ruby application, whatever other platform is, people are subscribing to notifications. And they also want to be able to send emails from this boundary. So I have a notifications module that I expose a public interface of, hey, any caller in the system could say they want to subscribe to platform events, whether that's like a user being created, someone just registering that you're going to get the event, and they can filter based on message passing. Or if they want to send an email in the system, they can call a function, right? This is very basic. But the question comes up then about this whole nested module thing is, why that at the top? Why notification subscribe, notification send email? Why don't I just call this nested module directly? And the answer is, like, one, it's better to encapsulate these things. That, first of all, we're using Amazon SQS for this platform, but the callers don't care, right? They're just going to get a message that said, hey, this user was created. So it's better from a design standpoint to have this boundary here saying, I just want to get a message when something happens on the platform, right? If we abandon SQS later because we rewrote all of our Ruby code, now we have to go find everywhere in the application that happened to know it was calling into SQS. It's just going to be much better code to put this at the boundary. And the same with sending an email. I could configure an email client in different environments and just have an email sent. Like from the caller's point of view, they just want to accomplish something, right? They don't really care that this is going over SMTP or going over Mailgun or any other service. So having said that, that doesn't mean that you will never, ever call a module dot some other module, right? Like if part of your requirements are like, hey, I just want to send an SMTP email, like that's what I need to do, that's what my caller wants to do, then you publicly module doc your SMTP module, and then callers call it, right? So we are giving suggestions to people to think about designing their applications, but they should be thinking about it the same way they design any Elixir structure, right? Just like we have Mix, like Mix has a Mix task module. So it's not that like Mix has to just expose every public function at the root level, but we want to think about the boundaries and think when it makes sense to expose the public APIs that we do. Sometimes it does, but oftentimes it's a better design to have the callers not care. They just want to accomplish a task in the system. They don't care that it's going over a SQS queue, right? So again, we are giving suggestions for people to think about. We're not prescribing you to adopt some holy grail of 100 lines per class, 4 arguments per function call, right? This is just us telling you what we think is going to lead to a proper design and the ways to think about designing an application. So that's 1.3. It should have been out by now, but it will be out real soon. No, I have to finish the Phoenix guides, so it's blocked on me personally, as well as the Phoenix channel protocol. There's going to be a second version of it that shouldn't affect anyone up in userland, but there's a race condition discovered that I think is rarely run into, but the only way to fix it was to make a second version of the protocol. I have it fixed on the server. Now I just have to rewrite the JavaScript client. So once I get that out and the Phoenix guides rewritten, we can get 1.3 final. So that's what I want to talk about with Phoenix 1.3. Now I want to talk about some kind of history of where the framework was, the goals that we had as we built each release, and kind of where we're going, where we see the framework growing in the future. So if we walk through the releases, like Phoenix 1.0, we had this tagline, productive, reliable, fast. It's still our tagline. If someone saw there's a new Crystal web framework that has a tagline that's remarkably similar. I forget the words, but it's like, I don't know, it's like fast, productive, reliable. It's remarkably similar. But anyway, we wanted to pitch this idea that we can give users a no compromise on speed and maintainability, that we can provide kind of this perfect mix of qualities that people weren't getting out of existing solutions. Usually it was kind of one or the other. And we were also advertising that we had microsecond response times, which was a big deal. So the goal with this, at least when we first started out, was that we were trying to convince you all here, you the developer, to bet your job, your own personal company, or your free time on the framework, right? Like early on in the evolution of Elixir, I was in IRC, and weekly I would just watch to see if the IRC active users in the afternoon were growing, and it was yo, we got 10 more here than last week. So our goal earlier on, right, was just convincing people to get involved, to check this out, and trying to convince them that we had some qualities that could give them big success. And this continued. So with Phoenix 1.1, we had 2 million channel connections. So we were able to get some really amazing performance optimizations. Some books started coming out. So this was some really exciting times for us. And we kind of were living up to the hype of, hey, we have this amazing VM we're running on. We can give you the productivity without sacrificing performance. And oh, by the way, here we can prove it. So this was really exciting. But again, this was we wrote blog posts. We made the front page of Hacker News, and our goal was still convincing you, the developer, hey, you need to bet your job and your free time. If you have a few hours a week, and you know that we can scale to millions of connections per server, this is going to get you interested to at least checking it out. And this wasn't to say that we weren't interested in getting this into production at companies. Our goal was to get developers interested and then have them sneak it in the back door, or have them go to their CTO or their boss and say, hey, we have to use this. And then Phoenix 1.2, we still took the deep dive into leveraging the platform, right? We were melting people's minds, distributed applications. We were applying cutting-edge CS research. So it was really exciting. For me personally, it was exciting because we were able to kind of showcase to the world what the Beam and the Elixir could do. So this was awesome from a personal achievement. I think from a technological achievement, it was a neat way to use CRDTs and CS research in a practical way. But the theme was we were still telling you, the developer, hey, we were applying these amazing things and utilizing this VM. So we were kind of on this trajectory of how much secret Beam sauce can we rub onto the framework to get some cool features out of it. But then we started to take a little bit of a more, I'd say, practical route here. So we melted people's minds with CRDTs, and then Phoenix 1.3, we're hey, the web directory moved. Design, think about your design, it's good. And most people have been yeah, I like this. That sounds cool. So we've been focusing a little bit more on we went and developed some really interesting innovation. But how can we improve developers' day-to-day life about just writing software, right? Programming is hard. So whether or not you can leverage CRDTs doesn't help you if your application is a disaster in a year, right? We want people to look at their application 5 years from now, 10 years from now, and be able to say okay, I can actually reason about this system still. So we're still focusing on you though, right? We're telling you we can relieve your pain, right? If you think about your design a little bit, a few years from now, you're actually going to still enjoy your application. You're not going to try to rewrite it for, Crystal. That's still our tagline. So this is a good thing, but it's a little bit less exciting than CRDTs. So this is where Phoenix 1.4 comes in, because we want to focus on monitoring and metrics. So this is going to be production level, robust insights into your running application. And if you're using the web, this includes things like health checks, and something that pretty much everyone needs. Every client that we have at Dockyard and in Plataforma Tech, the first question is, hey, how do I monitor this? How do I get metrics out of it? And it's doable. And we can point people towards hey, read this blog post. Hey, this person published a blog post. You can kind of stack these tools together, throw Xometer in, but use the Elixir wrapper. And so it's hand wavy, right? So I think we can do a much better job. But most critically, what we realized is that our goals have shifted a little bit. It's shifted to say okay, we're actually trying to convince your boss and your stakeholder that they need to bet the product on the framework and the platform. And this is actually a pretty significant shift and a pretty significant milestone for us because our marketing has always been about like how do we just get people interested, and now it's like we got developers interested. Like I think anyone, they may not be using Elixir or using Phoenix, but they at least, I would say we're still pretty small, but they're at least aware of our existence and our technical prowess. So now we want your CTO or your boss to come to you and say, hey, I heard about this thing that can save us money. And they've got all these things that provide great business value, like monitoring your metrics, like all these things that we can take advantage of. So we want to target more of a production level feature set to solve something that pretty much everyone needs anyway in the ecosystem. And I made this like terrible graph, but this is what I do, like just like my last talk with like the Phoenix and the umbrella. Like when I'm procrastinating, it's like, oh, I've got to make this thing, and it's taken so much time, but I got to do it. I don't know, and I feel accomplished. But I wanted a way to show like, you know, it's not that we're going to stop working on innovative features in the platform. It's that, you know, with the 1.0 release, it was just a matter of like, you know, we were just trying to get mindshare developers, right? We can't launch a product and target stakeholders unless we're like, you know, an enterprise. But for us, it's like we have to get developers involved from the beginning. And we did that by, you know, touting the benefits of the platform. And then we did it by showing that we're ROF scale, right? And things started to get, you know, uptick. Like, you know, people were getting excited because first it was Phoenix 1.0. They were like, wow, Erlang's amazing. And here's a framework built on Elixir that runs on Erlang that claims it's going to be ROF scale. But with 1.1, it was like, okay, millions of connections per server. So developers were getting more and more interested. And then we were like, CRDTs, distributed applications. So we were like at like peak hype and mindshare of like, we're doing amazing things on the platform. And then with Phoenix 1.3, it was like, there's a new directory structure. So it's not that our mind, like this is a bad thing, and not that our mind share is dropping, right? It's just not that we're not like keeping the hype of like, wow, new innovation, new features. But what we think we can do and focus on is like, okay, it's not that we have to like blow everyone's mind every 3 months, but we can say, hey, now we have metrics. We can actually provide these really interesting business values. And I think that stakeholder interest in mindshare is now going to increase, right? So I think it's kind of like this sinusoidal process of, like, notice how at the end of this graph, we get back into the hype cycle. So I think there's still some really interesting things we can do, especially around service discovery, distributed programming, that I've talked about in prior talks. So it's not that like it's boring features from here on out, but it's that we can take this cycle of how can we leverage the platform to do things that really no one can do or no one is doing. But then we need to also leverage like how do we solve the practical problems and provide business value to day-to-day users, right? So I think there's a good balance here where we can kind of go back and forth, and then we can trend towards world domination. So that's the goal. So let's talk a little bit about the plans. And again, these are super early, like very, very early. I've been trying to focus getting Phoenix 1.3 out, but we've been thinking about these problems for quite a while. So the APIs that I show here in the examples are prototypes. We're still in a research phase, but I do have a demo of something, at least a working prototype here. But the question is, like, you know, what does the current landscape look like for monitoring and metrics? And it's like we have all these software as a service solutions. They're often called like APMs, application performance monitors. And a lot of them are announcing Elixir support, which is great because these companies that are out there making money are like, wow, we see a big uptick in adoption of this platform, and we think that we're going to have a competitive advantage by getting involved in Elixir, which is great. But the side effect is, what we're seeing is everyone is re-implementing their own data collection, and they're often doing it really poorly. Like, a lot of them have their own agents running. They're calling them agents, like a collection agent. A lot of them are going to be implemented as ports because they wrote them in C so they can use them across all platforms. And everyone's doing the same data collection in different ways and often poorly. Or they are just collecting like web metrics and they're ignoring the wealth of information that the virtual machine has for them. So they're treating the VM as just like this dumb web language if they want to instrument Phoenix, when really there's a wealth of information that people can act upon that no one's collecting. So we want to be able to provide some common interface for data collection and reporting that you can still report to all these services, because these services provide really great value, but we want to solve the hard problems for them so that way you can just wire these up easily. So this is like the preliminary plan, And first of all, I should note that this is going to be like a standalone library entirely decoupled from Phoenix. So the goal is to have this be like the library that the Elixir projects use if they want to have instrumentation. And this is going to be extracted and generalized from the instrumentation work that we have in Phoenix now. People may not be aware that we actually do have endpoint instrumentation as of like Phoenix 1.1. That's there and allows you to instrument core events as the framework is making requests. And it's actually really neat. We're going to talk about how it works. But we want to generalize that because there's no reason that you should have to have that coupled to the framework, right? This should be a boring, low-level library that Ecto, Phoenix, any library in the ecosystem can leverage, and then people that care about instrumenting it can hook into it. And one thing we want to do is have robust VM-level information. Again, I think there's a wealth of information there that people either aren't collecting, don't know exists, or they know exists, but they don't know what it means. So I think we could do a great job by surfacing this information and actually saying, like, hey, we think, you have 2,000 ETS tables. Like, that's kind of weird. Maybe you should look at that. Like, there are some things that we can look at system limit-wise in the VM and highlight and say what may be going on in the next place to look. And again, we want to have extensible reporting to third-party services. Like, we don't want to replace Datadog or New Relic. We want to allow you to collect data and report to them, but in the most efficient way possible. But if we think about, like, what are the essential things that a monitoring metric instrumentation system needs, is like, one is it must not take out the application under load. Like, in an effort to do performance analysis, like, it shouldn't actually take the application out. And I've seen that firsthand. Like, I'm not going to name the library, but this is the problem with some of these Elixir agents that get added for a service, where they'll be like, oh, Gen server is concurrency, so I can just do a cast for every web request to this single process, and I can get really awesome performance monitoring. So I've actually seen this. I was doing some performance load testing for a client, and I hit the application with some load, and like the application completely died. And it was like, whoa, something's going on there. And there was code very much like this. And the problem is, like, in an effort for them to monitor their performance, they reduced their application to a single thread and proxied everything through a single gen server. So this is a problem. And these are the kinds of things that we're seeing with people integrating to these third-party services. So our goal is to take care of the data collection for you. You say what data you want to collect, we'll collect that in the most efficient way we can, and then you can report it to these services. And then the second part is I really want to see the Beam treated as the novel platform it is. Again, we want to surface critical VM information. Like, the Elixir is way more than just the web. Web metrics are extremely important, right? Like, what requests are being tied up, what are our slowest requests, what's hitting the database the most. Like, that's important. We have to collect that. But then we also want the wealth of information that we have from Erlang. Like, how many processes do we have in the system? Are any processes growing with unbounded do any processes appear to be have an unbounded message queue? Like, these are things that are so helpful when you're trying to do performance analysis, but almost none of these services collect or care about. And we also think data collection must be trivial to define, right? It should just write a function should be the answer, right? There shouldn't be some advanced thing that you have to do to hook into the system. It should just be if you care about a specific metric in your domain that we don't know about. Like, we know that you probably want to track CPU or memory usage, the VM stats. We can provide helpful functions for that. But if you want to see what the active user count is for the last hour, like, that's something that you need to write, and we should make that super easy. And then again, we have all these third-party solutions. It should be super easy to interface with them. Like, we don't want to reinvent the wheel for everything. We want to be able to have everyone stop reinventing the wheel and share some common core API, and then do what they're good at, and that's charging you for money and providing value. And then lastly, like, my personal goal is that we need to make metrics easily accessible and actionable for non-experts. And Daniel's visualization talk yesterday made some really great points around this. That I think that, again, we have this wealth of information, and I have gone on site with clients that they have a team of several Elixir developers. They're getting a ton of value out of the platform, and they don't know what an ETS table is. And that's not their fault. That's not a problem. They're actually they're seeing great performance, great business value, but they're having problems. And if we could just surface this information, right? Like, there's no reason, it'd be trivial to write a function to say like, hey, given this process, if there's 10,000 messages in its inbox, maybe we could tell the user on a web page like, hey, you should probably look at this process. It looks like it has an unbounded message queue. Like there are obvious things that we can surface and give actionable insights for that I think would be immensely helpful to people. So if you're not familiar with monitoring and metrics, it's just pretty basic as far as like the kinds of instrumentation you want. So if you want to have like a gauged metric, it's just an instantaneous measurement of a value, like what's the CPU usage? And if you notice like a gauge here, do you see the really, really awesome title of the talk, Gauging Progress? That was easily a day of work. So I made that front page slide, and I was like, all right, I'm done for the day. But no, so a gauge is just like an instantaneous value. It's the easiest thing for us to collect because we just call a function, and whatever it reports is the value. And then we have meters and timers, which are more complicated just to do in a performant way. And this is what we see people doing incorrectly, where if they want to do like requests per second, like give me the rates of events that something happens over time, you want to make sure that you do this in an efficient way, because if you have 10,000 requests a second coming through the app, you can't just call a single gen server and say, hey, calculate this. And then often people want like a statistical distribution over that. Like I want to know the requests per second, but I also want to know like what are my 99th percentile response times. And then the last part of this is an instrumentation where we want to have compile time hooks into application events. So if Ecto is doing queries, it'd be nice if we could just ask Ecto like, hey, anytime you do a query, please tell me how long it took. That way I can report it to Datadog or New Relic. And that is what we want to include in this library. So this is a preliminary API that I've put together. And this is the kind of things we're thinking about. Like I've named this Project Metrics, but it's actually an Erlang OTP app, so I have to come up with a new name. Xmetrics, that's what Jose suggested. So no, we're not sure we're going to name it. But the goal is like this isn't going to be some like massive framework, right? This is something that ultimately is going to enable some neat features up in the webland in Phoenix, which I'll show you. But low level, this is something that we want packages in the ecosystem to rely on, and it's just going to be like a boring package, right? Whether it's named metrics or metrics ix, I'm not sure. But the goal is you just write functions that collect data and extract it out of the system. So in this example, let's say like I want to have a gauge for like what's my CPU usage in the system. Like I could just set up a supervision tree with this gauge function that just builds a worker that says, hey, every 1 second, I'm going to call this function, and you should report a value to me. And then you write a function, and you can hook into Erlang CPU sup to pull out the CPU usage. And this is the way you can sample any data you want and collect it in an efficient way, especially when we get into meters, right? Oh, I'm sorry, one more example. Let's say that you want to calculate something that is specific to your domain. Well, then you can just set up a gauge for like active users. Hey, every 5 minutes, I'd like to know like how many users are on the system. And this is going to depend on your app. Like if you have a channel application, like maybe the number of sockets that have been connected, but if you have a REST API or some person logging in with a form, like it's going to depend on your app. So I can just write a function that said, hey, Ecto, give me the users whose last request was in the last 5 minutes, then return that value. So you can surface any kind of data you want by writing a function, and that's the whole goal. Like we want to empower you to collect the data that's important to your platform. And likewise for meters, if I want to say like, hey, I want to track requests per second, I can set up a meter and say, hey, every second I want to get a rate of this value being marked. And I can hook into Phoenix instrumentation today. So like this works. The way Phoenix instrumentation works is there's a callback that happens when we start to call some instrumented code, and then we stop the instrumentation and give you how long it took. So you could hook into that today and say, hey, anytime Phoenix had a request come through, I'm just going to mark the request meter with the time difference. And that way, it's going to track the requests. It's going to use an ETS counter internally. So it's going to try to do this in the most efficient way possible. That way, I'm not worried about, hey, if I want requests per second, I actually have to have my throughput, right? This is going to be something that's very, very fast. And I want to talk a little bit about, like, metrics is such an overloaded term. And then the things like on the left are the things that like all these solutions on the web today, New Relic, Datadog, like they're good at. Like, hey, if you just spam like a UDP port or you have a C agent running, we can give you requests per second. We can do statistical distribution. We can tell you, hey, here's how long this plug took in your controller. And if you want to report active users to them, they have APIs for you to do that. But what I'm interested in is more VM level metrics. Is like we want to provide system limit information or make it easy to get this out of the system, right? Like if you can graph the atoms over time, or say like, hey, this atom table looks like you have a memory leak. Like that'd be something extremely beneficial to the user. Or you can say, hey, you're running up against the process utilization limit. Like so maybe your system limits need to be upped, or maybe you have a leak somewhere. Like this is something that we should be able to detect and report to the user. So now we're going to talk about Endpoint Instrument, which we want to extract and generalize and kind of use this as a base to make this library. And I think, is Andrea here? I told him that he'd make a cameo. There he is in the back. So Andrea actually wrote Phoenix Endpoint Instrumentation and did a really, really great job. And it's actually some fun code to revisit because we were able to leverage Elixir's metaprogramming quite a bit. So let's say you want to instrument this piece of code here. You wouldn't do this because it would be almost instant, right? Like I don't know if anyone's ever had a slow render time. If you have, please let me know. But let's just say for simplicity, like I want to know how long it takes to render my templates. That way I can brag to all my friends that my render times are like microseconds. Well, the way you can do that today is you can just say in your controller, like instrument render, you give it some name. So this is the render time, and then you provide some kind of runtime metadata, like, hey, here was the view, or here was the template I'm rendering, and then you just wrap that in a function. So very trivially to wrap a piece of code and instrument it. Not that impressive, but the cool thing is what we're doing under the hood to make this efficient. For people that care about instrumenting this, it's just going to be a callback module that we saw earlier, where they get like whatever the name of the event was, they define a start and stop event match for it, and then they get that runtime data. So they can say, oh, you were rendering this template, and then I'm just going to log like, hey, this template took so long to render. Like anyone that cares about this, or any module that cares, any number of them can hook into this event now. So the goal is, like if Ecto wanted to say, hey, I want people that care about the repo query instrumentation, any number of them could hook into that event and then have this callback run. And this is what Phoenix is doing today. So this is from the Phoenix controller pipeline. Every time a controller is invoked, we hook into instrumentation and say, hey, we're going to instrument the Phoenix controller call event, and then we run that code. And then if someone cares about instrumenting this, like I can write my own module, like I want to just make a demo logger, I can hook into that instrumentation, and then I get the diff of how long the controller functions took, and I can log it. So this is all there today, and this is actually how the Phoenix logger works today. And anyone here that has a Phoenix app can hook into this. So we want to take this idea and generalize it so that any library can use it. And one thing we're taking advantage of is some pretty interesting compile time injected code, which Jose fortunately crushed my dreams earlier today that we're going to have to change this a little bit. So we can still take advantage of compile time information, but to generalize this across basically any library, we'll probably have to turn some of this work into runtime. But the way this works is anytime you call instrument in your app, let's say that you have no instrumentation module that cares about the my event or the render event, you're not going to incur any costs. Like we're basically going to compile that as a direct function call. So it's almost like the logger calls in Elixir. We're able to intelligently at compile time say, does any instrumenter module actually care about the specific event? The fact that we're saying that we can instrument it doesn't mean that we're incurring a cost if no one cares about it. Likewise, if we have 10 instrumenters in our system, we don't have to call all of them to say, hey, please instrument this if you care about it. We actually only bake in like literally these lines of code. We don't even do a map. It's just like the first one is a result 0, the second one is going to be result 1. We run the code and then call each of those again at the bottom with the result, and we return the final value. So we're doing some really interesting compile time work to make instrumentation as cheap as possible, because the goal is like in an effort to do performance analysis on your code, like the worst thing that we can do is actually really hurt your performance, because then people are just going to like be like, well, I hope it's fast, but I don't want to measure it because in production it's going to take my app out. You know, it's like we're going to do the hard work for you so you can get insights into these things and actually act on them. So now I have a demo. And again, this is like a couple days of channels work. So this UI is not what I am going to ship. But the goal is that anyone that cares about metrics in their system is going to add their supervision tree. So this is the actual running app. So let's say I have this metrics demo application. This is the code I showed you. Let's say I care about tracking memory, CPU, and processes and requests per second. Like it's literally Very similar to what I showed you on the slide. I'm hooking into Phoenix Instrumentation to do requests per second. So let's see how this works. So this app's up and running. The channel code on the client is going to pick up, like, it's hooking into the instrumentation as a reporter and saying, hey, please tell me everything about gauges and meters that you have. And it's just to display them. So anything that we care about will just pop up here. And I'm going to hit this app with some load, and we should be able to see in real time like the request per second for this node. And the goal is that when we're done with this, that you can fire up a web endpoint, and then you can see all nodes in the cluster, what their requests per second are, how each of their health is doing in real time, without taking out the system, which is important. So if I throw some load at this, we can see we're at about 5,500 requests per second, and this is just reporting in real time, using S behind the scenes to count, using Phoenix Instrumentation. And you can see it maxed at about 5,300, and then work is reporting about 5,200. So accurate and pretty fun to watch. And the cool thing is, if we turn off instrumentation, there's like a very negligible impact, maybe a couple % to monitor requests per second. So every request, 6,000 per second is running through that instrumentation block marking that meter, and it almost has no cost, which is pretty fun. And then like we can get more information, or like system limit level events, like the number of processes in the system versus the maximum that we have configured for Beam. Like let's say we want to go through like a couple 100,000 processes here and spawn them, and we can see what happens to our system limits. So let's say I'm going to spawn a process, and I'll have it just randomly sleep for let's see, up to 20 seconds. What is it? Random uniform. And if this works, it'd be a miracle, but 20,000. Someone saw that immediately, and then they were just waiting for the ultimate fail. Okay. So the cool thing here is, like, in real time, people can start seeing, like, whoa, something's happening to my system. Either I'm exhausting resources, or I have something that needs to have something take a look. And then as these things are dying, we're just going to report those Beam stats, right? And this is, like, trivial to surface. Like, the Beam exposes, like, all this. It's kind of like when you first discover ETS tables, and you're like, this is just here? Like, it's kind of like the API is kind of weird to surface, like, to use, but it's all here. Like, you just call a function. This is kind of like what happens when you get into these. Like, I can just ask the Erlang for, like, give me the system info for the process count and process limit, right? Like, these are things that we can hook into and just show the user. And this is what I want to do. Like, this isn't going to replace your metrics from New Relic, or if you're using InfluxDB and Grafana. This isn't going to replace that, but the goal is to have you at least be able to have actionable insights out of the box in the framework with no third-party dependencies. And then we can do more intelligent things like, hey, like, here's the top 10 processes by message queue. We can develop heuristics like, hey, if there's 10,000 messages in an inbox, like, there's probably a problem here. And we could tell people maybe where to look, or link them to a guide on pooling. So there's all kinds of things I'm interested in. Is we can get these metrics out of Observer, and it's really important to have our metrics collection be production level. So we can have these advanced services be able to collect and report them for you, but we also want to give users actionable insight into what's happening in the system in real time. And then you can provide any kind of logic on top of that you want by writing a function. So that's the goal. Like I said, this is early, and we won't have to have something pushed soon, but the goal is eventually we'll have a Phoenix metrics project that's built on top of this metrics library that lets you do something like this. So the final goal is, like I said, standalone library that anyone can use, and then a Phoenix metrics project that's going to use channels that anyone that has a current Phoenix app can just add the dependency and say, hey, I'm going to forward /metrics to Phoenix metrics. And oh, by the way, here's some sources to pull data from. And then you can visit /metrics and then, like, oh, just a wealth of information and insight into your system. So that's the goal, and I think we can accomplish it. And it's neat that, like, we can leverage Phoenix to give you a neat interface insights into this data, but internally we can use a library that everyone can take advantage of outside the context of Phoenix entirely. So monitoring metrics, not coming soon, but coming next. First, I have to ship Phoenix 1.3. like I said, the only thing I have left to do is to finish the channel protocol, which is just JavaScript, and the Phoenix guides, which is going to take a bit more work. But we should get that out. I don't know. I've been saying it by the end of the month for the last 4 months, so I'm just going to say soon. When I get back from this trip, I'm going to start rewriting the guides. And then following that, we'll have the Phoenix 1.3 book updates, and then we can continue researching monitoring metrics, especially around existing Beam solutions. So, the exometers out there, there are several metric libraries, and we want to see what's available in the ecosystem and how do they integrate specifically with third-party solutions, because that's the most important part. It's how can we develop a common interface to all of these systems, that way everyone can hook into our data collection, and then you can report it to whatever system that you desire. So then again, a metrics package with a different name, release it to the world standalone, and then build a Phoenix metrics package on top that just kind of gives you a nice channels interface that you can hook into an existing Phoenix app. So that's it. Thanks for coming. And then, I'll be around, so if you have questions, I don't know if we're doing questions or not. I'll take questions if people want to ask them.
So if you have questions, please just come up down here and ask a few questions. We've got a few minutes.
It's a nice one. So you're obviously a busy man. Is there things that people can help you with Phoenix?
Yeah, so definitely. So if you're, I tried to hopefully mention we had the Paparazzi project, the Wobserver folks. I forgot to mention. We definitely want to collaborate with them because they're doing some neat data collection and visualization right now, and see where there's some common efforts going on. But for everyone at large, what I tell people is a lot of people ask me, I'd like to get involved, is there anything I could help with? I get that question constantly, which is great, but my response always is, usually people feel, I've been through this myself, so people feel like they want to get involved, but they need to be allowed to get involved. So what I tell people is kind of break down any barrier that you feel that doesn't make you worthy until someone says, yes, please do this, and just start getting involved. So visit an issues list on Phoenix or Phoenix PubSub or any project that you care about and see what's going on. And if you find a point where you can contribute, however small, just start sending pull requests. And then the maintainer is going to be like, wow, this person is great. This is hugely helpful, and that's kind of how you can get a jump start into the ecosystem. So I would say, yes, we could use help, and my answer is always check the issues list, but I think it's important to let people know that just jump in, because 3 years ago that's what I did, where it was I'd like to get involved in open source, and then it's oh, I will write a web framework, and now I'm up here. But for a while there was this barrier where I was I didn't feel worthy, the world could see my code, or I could release a project. So I would say first break down that barrier, and if you're interested, just get involved. And people will happily accept your help.
Anyone else want to come up and ask a question? All right, let's give Chris another round of applause.
Thank you.
I want to thank everyone again for coming to ElixirConf EU, and I really hope to see you again next year. We don't have a location exactly yet, but I'll say this, we're leaning a little bit towards Prague, so hope to see you next year. Take care. Safe travels.